Okay, we're on page 15 from chapter 2, which is the last section, section 7. Difference between problems upcoming and the previous section. On the previous section, they gave us these inequalities. This section, they're giving us none. We have to actually come up with our own. So these are the strategies for problems in this section, which is a linear programming. Step 1, we need to define all variables. Once we define the variables, we need to write the constraints as a system of inequalities. Then we need to graph the system and find the coordinates of the vertices of the polygon that's formed. So 3 more steps, but we're basically doing the same idea as the last section, but we need to come up with the inequalities and go from there. Then we need to write an expression whose value is to be minimized or maximized. That would be step 4. And then step 5, we need to substitute the values from the coordinates of the vertices into the expression. And then the last step is really to answer the question. Usually a lot of these problems says how many units will produce the maximum profit. It's profit. It's usually answer the question. If it's a profit problem, we would select the greatest or least profit. Okay, example 1. Suppose a lumber mill can turn out 600 units of product each week. To meet the needs of its regular customers, the mill must produce 150 units of lumber and 225 units of plywood. If the profit for each unit of lumber is $30, profit for each unit of plywood is $45, how many units of each type of wood product should the mill produce to maximize the profit? So step 1, we need to define the variables. We could say X is the number of units or the amount of lumber produced, really units of lumber. And the other variable, Y, could stand for the amount of plywood produced. And before I try to graph this, I need to figure out my inequalities because I want to know what scale I need here. Should I go by 1s or 50s, 100s, whatever? So I'm not ready to graph this yet. So let's come up with some inequalities. They can turn out 600 units of product each week, no more than that. So the amount of lumber plus plywood is less than or equal to 600. And they must produce 150 units of lumber and 225 units of plywood. They must produce at least that amount. So X is greater than or equal to 150, and Y is greater than or equal to 225. And then before I try to graph this, I'm going to find the intercepts. Here it would be 0 and 600 and 600, 0. So I'm going to go by 50s. So there's no like right or wrong. You just have to start the problem, and once you find the intercepts, that'll help you figure out a good scale to use. Like obviously by 1s would be pretty bad here. Okay, so now I'm going to graph this. So first one, I just find the intercepts, and it's less than or equal to that, meaning I'm going to shade below here. Then X is greater than or equal to 150. That's a vertical line. And if it's greater, we're going to shade to the right. And then last, y is greater than or equal to 225. So it should be this region in here. So I need to find these vertices. This is on 150, 225. This is 150, 450. And I know that because if this equation is x plus y equals 600, if I can't tell, I can just plug in 150 and solve for y. Here, y is 225. So if you don't know what x is, you plug it in. And if you carefully plug in, you get 375. So those are our three vertices. Then we write an expression whose value is to be maximized or minimized. That looks like this. If the profit for each unit of lumber is $30, so that's 30x, and the profit for each unit of plywood is $45, here's our profit function. And then we're going to plug in all of these vertices. And what we want to do is figure out, we want to answer the question. We want to maximize the profit. So we want to know which ordered pair would maximize the profit. So we're going to carefully plug in. And then here, and obviously calculator would help you guys. And if you plug in carefully, first one I get 14,625. Second one should be 24,750. And then the last one's 21,375. So the question said how many units of each type of wood should be produced for the maximum profit. If that's the maximum profit, these are the values. So we want 150 units of lumber and then 450 units of plywood if we want to maximize the profit. So each problem, we're just following the steps here for the linear programming procedure. So that's example 1 from page 15.